TPU in AI. Here is your same structured beginner-friendly content for TPU, Tensor Processing Unit in AI, Beginner Level Introduction. A TPU, Tensor Processing Unit, is a specialized chip designed specifically to accelerate AI and machine learning tasks, especially those involving deep learning models. Unlike general processors, CPUs means general tasks, GPUs means parallel tasks, TPUs means AI-specific tasks. TPUs are developed mainly by Google to handle operations like matrix multiplication, neural network training, deep learning inference. They are widely used in large-scale AI training, cloud AI services, natural language processing, computer vision. This topic helps beginners understand how TPUs are built for fast and efficient AI computation. What is a TPU? A TPU is a hardware accelerator designed to perform tensor operations efficiently. In simple words, TPU equals a chip built only for AI calculations. Key idea. Instead of general-purpose processing, TPU does curly AI-specific operations, high-speed matrix computation, efficient deep learning. What is a tensor? A tensor is a multidimensional array used in AI. Example: tensor equals 1, 2, 3, 4. TPU versus CPU versus GPU. Feature: TPU, GPU, CPU. Purpose: AI-specific. Parallel computing, general computing. Speed: AI. Very high, high, lower. Efficiency: optimized for AI. Moderate, low for AI. Use case: deep learning, AI plus graphics, general tasks. Example of matrix operation: A equals 1, 2, 3, 4. B equals 5, 6, 7, 8. 8 double double H. Result equals A00 times B00, A10 times B10, A11 times B11. Print result. TPUs are optimized for this type of operation. Simple TPU concept example: Python. Def multiply matrix data. Return x times 2 for x in row, for row in data. Print multiply matrix 1, 2, 3, 4. How TPU works. Step 1. Input data. Data equals 1, 2, 3, 4. Step 2. Perform tensor operations. Result equals x times 2 for x in row, for row in data. Step 3. Accelerate computation. Print fast tensor computation. Step 4. Output result. Print result. TPU in deep learning task. Train. Neural network. Print. Using TPU for training. TPU in natural language processing text equals AI is powerful. Print. Processing text with TPU. TPU in image recognition image equals cat.jpg. Print. Analyzing image. TPU in cloud AI. TPUs are widely available in cloud platforms like Google Cloud. Print. Running AI in cloud TPU. TPU architecture. TPUs use, end quote, matrix multiplication units, high memory bandwidth, optimized data flow. Full menu-based TPU example: def process tensor. Data is list map input, enter numbers split. Print processed x times 2 for x in data. Def train model. Print training model using TPU. Def analyze data. Print analyzing data with TPU. While true, print N1 process tensor. Print 2 train model. Print 3 analyze data. Print 4 exit. Choice equals input, enter choice. If choice equals 1, process tensor. Elif choice equals 2, train model. Elif choice equals 3, analyze data. Elif choice equals 4, break else print. Copy. Tensor operations, AI hardware acceleration, deep learning optimization, matrix computation, cloud AI systems, high-performance computing. Real-life analogy. TPU is like a specialized factory machine. Check. Built only for one task. Extremely fast and efficient. Ways to improve a project. Use TensorFlow with TPU support. Train large models. Use cloud TPU services. Optimize tensor operations. Work with large datasets. Compare TPU versus GPU performance. Use distributed training. Study hardware architecture. Common mistakes beginners make. Next, thinking TPU is same as GPU, not optimizing code for tensors. Next, using TPU for non-AI tasks. Next, ignoring data pipeline. Next, not understanding matrix operations. Where it is used: deep learning, natural language processing, computer vision, cloud AI, large-scale training, research labs, enterprise AI, recommendation systems. Large systems may include TPU clusters, cloud AI platforms, distributed training systems, AI infrastructure. Simple definition: TPU, Tensor Processing Unit, a specialized processor designed to accelerate AI and deep learning tasks using tensor operations. Final summary: TPUs enable: faster AI training, efficient tensor computation, scalable AI systems, high-performance AI infrastructure. They are a key part of modern AI hardware systems.